Thanks for coming out on Friday, Atomic Friday. So we've got a couple cool things to show today, if we have time. But the three main things we wanted to show, we brought Tony Lambert on, one of our detection engineers, who's been working on some Mac OS and Linux tests that we've shipped into the Atomic Red team. So he's going to give some background on what those are, why we created those, and how you can leverage those inside of Atomic Red team. And then Mike has been updating some of our install and so install scripts, and then we also have a new like invoke all function. So if you just want to run everything, pretty easy way to do that. We just collapsed and abstracted some of the complexity around like I just want to run every single test, at least on Windows. So that's for our PowerShell execution framework. So Tony, if you're good to go, I think I'll go ahead and hand it over to you and just kind of be on standby.
That works. Casey and Mike invited me on today to talk about 3 new chain reactions that are in the Atomic Red team repo. 2 of them are designed to go towards Linux. One's designed to go towards Mac OS. The way this kind of got started was to address a unique problem we had at Red Canary with folks that were coming on as prospective customers, where they weren't entirely sure how to test Mac OS and Linux systems. They could test Windows no problem because a compromise on Windows systems follows a fairly island hopping type pattern where there's a compromise, gets to system, you're king of the island, now that you can figure out how to get to the next island. And when they started looking at Mac OS type compromises or Linux type compromises, it wasn't exactly the same kind of island hopping thing. Sure, you can do that, but what we've seen more in the last few years is some form of fake update malware for OS X, Mac OS systems, where you install a Trojan and behind the scenes it does something else. Or on the Linux side, we found out the hard way that there's not a whole lot of documentation around aptX trying to compromise Linux systems. But if you search hard enough, you'll find that everybody and their brother has a DVR that's been compromised by a crypto miner, or everybody has had a Redis server that's been compromised by a crypto miner, something like that.
So is that EDR for DVR?
I've been wondering that, but apparently you can do AutoD on your DVR.
There you go.
Where there's a will, there's a way. We can put telemetry on it. So yeah, that's been an interesting sort of thing to dive into. And when we do any sort of behavioral testing, when we do any sort of atomic testing, it's very important to have it in the context of a larger attack. It's very important that it's not just a user account being created, or it's not just a file being modified. We need to have it as part of a larger kill chain for that to actually have some sort of effective meaning. If it doesn't have effective meaning, it frustrates customers, it frustrates community members, it frustrates us, it frustrates everybody. So without further ado, I'll take you into the chain reactions here. Share the screen. Red Team Google Chrome. Here we go. So the first one I wanted to go over is the CookieMiner one. This is designed to go to emulate the CookieMiner malware that was observed on OS X systems in the last few months. Something that we've seen more on OS X systems, on Mac OS systems, is there would be a legitimately signed fake update, something like that. Then when you install the fake update, when you install the malware that you think is good, it'll have a shell script or something else going on behind the scenes that's doing all the actual evil stuff. And in most cases, it's doing some sort of recon, some sort of data collection, package it up, send it home. In the case of CookieMiner, it would go down the line and look for specific cookies in the presence of specific cookies in Safari's cookie store, which we've added this as a test, collecting data, staging it for exfiltration. Since a real true simulation is going to have some network connections that are going to be kind of risky to do, we simulated the network connections here by just doing curl calls. Then at the very end, provide a couple of areas to do persistence simulations. With CookieMiner specifically, it left a couple of launch agents on a victim's computer. One of them was to trigger a Python Empire agent, or Python Empire agent. The other one was to actually keep the crypto miner, the binary payload, running whenever you started up your computer the next time. And to simulate the miner payload coming down, we got together a simple C binary and compiled it for Mac OS. This is something that you could replicate on Linux platforms too if you wanted to recompile that binary. Although the launch agent part definitely wouldn't work.
So Tony, this is a part of the, like if people want to test this, it's in the chain reactions directory. Oh, yes. So that this is where we put, tests that occur in sequences like you have there. So there's a number of those in there, but maybe just, so atomic red team artifacts and then what we call chain reactions.
I'll drop the CookieMiner stage 1 into the Atomic Slack right now.
Okay, cool.
So everybody has it. Yep.
Yeah. So the stage 1 was just showed, and there was a second stage that was a Python script. And since in CookieMiner a Empire backdoor was used, we included a simulation of an Empire backdoor, cut it off right before the whole network connection part happened. It's a controlled network connection that doesn't actually do anything. It basically just says, hey, does this page exist? And it doesn't, so the connection just dies. But if you wanted to take this part and hook it up to your own Empire instance in your environment, you could probably do that. But the base 64 encoded version down here is what will execute.
It's a really, really cool way to like showcase artifacts, chain reactions, because like our back in the day ones were very just like all in one, and this is great because you're making multiple calls out and pulling things down. It's very cool.
Yeah, the cool thing about this is the grand majority of this was pulled directly out of CookieMiner payloads, and the same will be for the rock and roll chain reaction talk about in a second, where I started with the payloads themselves, like the actual malicious payloads, and took all the fangs out that I could and got it to where, it's safe for public consumption. All right, let's take all the stuff that we would want to detect on, that people could actually detect on, put it into the chain reactions and let her go.
So just to make sure everyone's clear on that, Tony, the lines 1 through 14 is basically the Python script that you have base 64 encoded on line 25, right?
That is correct, sir.
Cool. And have we considered putting coin mining into Atomic as a way to fund the project?
If you could get that into GitHub, no.
All right, carry on.
There is not an Atomic coin, Casey.
Atomic coin.
Yet.
And the actual launch agents that go along would look something similar to this that you would just download. And again, this is the same Python that was in stage 2, in the stage 2.py. I just couldn't really include as many comments on this one. But that was, again, this is pretty much how CookieMiner worked in real life. The payloads work pretty much the same. We just defanged all the payloads to where it's reporting back to something safe. And if you want, you can modify it to where it can even report back to your own Empire instance and do a little more intense simulation of your environment. So I guess the next chain reaction.
Yeah, real quick on that. Oh, sorry. Real quick on that. Yeah, on that launch agent, those are, I guess, kind of like, I'm not completely familiar with the Mac side of this. So like with this plist in particular, if I drop this on my box, like, is this like the persistence portion of it? Like it's going to run every time my Mac turns on kind of thing? Is that how this looks?
It should. Think of it as on the Windows side, a startup menu shortcut.
Okay.
A startup start menu shortcut. It's
very
the
cool.
Same sort of fundamental concept. It's a XML document that it'll take in some program arguments here. We're telling we want to launch Python, Python-C, and then all the Python code. And then when this plist is loaded in, whether it's loaded in part of a script, loaded at boot, something like that, it's going to boot this up and execute.
That's awesome.
Kind of a funny thing when I started looking into the CookieMiner stuff was the technically when you looked at the payloads, there were 2 Python agents, and the launch agent Empire agents reported into a different port than the one that was used during exploitation. So it was like the adversaries in that case had one port specifically dedicated. Okay, these are the ones that are currently exploited. These are the ones that I'm going to come back to after the fact. And it's something to think about in your environment. Maybe you want to have something like that.
Hey, Tony, can I ask one last question before we go to the next one?
Feel free.
Is there, do we have a public reference for CookieMiner or a report that we could share with folks that, because these are the actual payloads or artifacts to test, but I'll just make a note and follow up. Maybe we can tweet it out or post it later. But
oh yeah. So the references that I primarily used, I believe was Palo Alto Unit 42.
Okay.
They did a fairly good article on it. There was one other that I can't remember, but I can go and look up after the fact.
That's fine. Yeah, we'll follow up. No worries. Thanks, Tony. Awesome. We can move on to the next piece there.
No problem.
I Googled CookieMiner and I got a bunch of cookie mining websites.
So the horrible part about it too is like if you do Google CookieMiner and you start looking at articles, every Bitcoin exchange news org in the country like has an article about this. It's amazing. Like I was getting stuff into Feedly for days.
That's great.
So you guys have any more questions? Is it okay if I do the rock one?
Yeah, that sounds great. I think this is good stuff. Yep, carry on.
Yeah, rock and roll.
So rock and roll is another chain reaction that is designed to emulate a little bit of the threat actor Rock, who would target web applications on Linux systems and then cause a crypto miner to be downloaded and just run in the background and keep going and gather income for them. And it's a multiple stage script, kind of like the CookieMiner part was. This one's a little bit different though. To start off with stage 1, there's just a little bash C command or wget out to bash. If you want, we can use a obfuscated part of an obfuscated version of the script, which was pretty much how Rock used it. They hosted a base64 blob inside pastebin, and then it would deobfuscate on the fly and execute. If you're not comfortable doing that, there's also a decoded version of the next stage in GitHub. And the reason starting off with a bash C, what we see with exploitation reports for all of these different web apps, when there is a remote code exploitation vulnerability that is present inside a web app, usually attackers will have one command that they can issue. They'll have some sort of JAX-boss, some sort of exploit code that will let them plug in a single one-line command. And what they will pick is something like bash-c and then have all this inside that bash-c so that whenever that bash command runs, it'll run everything that's inside it, kind of like a command/c on the Windows side. And the second stage, I'll just do the decoded one. The base64 obviously is a chunk of text, so that's not going to be very good to walk through.
So these are all the actions. So the rock and roll gets that one chance to run one command. It reaches out and pulls this down, and then begins executing all these different components.
Right, and the function calls, of course, are at the bottom, A, B, and C. And we have the different opportunities for persistence in our little A function, where it's removing an immutable attribute, modifying cron tabs for persistence, doing a little bit of time stomping. This was something that Rock did that was kind of interesting to me, was that it would take the timestamps from bin/sh, which would obviously have timestamps from its last update or from its system installation, and modified the timestamps of their custom created cron tabs with the timestamps bin sh.
And that would probably be a way to confuse a defender looking for like things that have arrived at a certain interval, right? So like,
absolutely,
you find a compromised host, you're looking for like new files. If you time stomp it, it looks like it's been on there for a year and a half or whatever this timestamp of that other file is, right?
Absolutely. Anything to slow down any sort of forensic investigation, anything to slow down a defender and make them realize or make them not realize that there is a there's a payload existing on the system. Then the B part is the part that actually downloads and executes a payload here. And again, we have a simulated payload, which is atomic hello. But if you wanted, you could simulate with an actual miner payload, such as XMR stack or XMRig, something that you can control. And the reason we categorize this as masquerading, it seems like, okay, this is a weird process name to pick. This is actually something that was picked by Rock. K-Worker DS is designed to masquerade as a K-Worker process on the Linux system. If you've ever dealt with Linux systems and you do like a PS-A to look at all processes that are running on your system, you may notice a few odd ones that have brackets around them, like K-thread, K-worker, some that start with IRQ, a few different ones. And those are kernel threads that are executing as processes. It's just PS will enumerate them the same way the processes do. So our adversaries and their real-life malware are trying to masquerade as kernel threads so that whenever you Google what's K-worker and you see, oh, K-worker is a kernel thread, we're not going to try to kill this process because we're too nervous. We don't want to kill the system. So we've got that part in here as well.
And that's pretty consistent, Tony, across distributions. Like that's a Linux process enumeration, not specific to a distribution, right?
Right. And it's something that's seen in other mining, in other crypto miner type scripts as well, because other crypto miner type scripts will also impersonate process names starting with IRQ and some really odd ones that will make people like very scared when they start Googling. And the key is to have a larger context when you're detecting them. For example, K-worker, technically it's a kernel thread. So you're never going to see it backed up by a legitimate binary whenever you go and you search out on disk to find what the binary is. So it would definitely never be running from a temporary directory.
That's a good point. Yep.
So that's some fun stuff on how to detect some of that. And my favorite part is the C part here, where if you start going through this part, this is the part where Rock and other actors similar to Rock will start killing other crypto miners and other malware that they find on the system. Turns out bad guys don't like to share resources with other people. They like to be the only game in town. So they'll list out all these different lists of crypto miners that they know of and try to kill each one of them. They do some quick process recon and figure out, are there any processes that may be doing crypto mining? Are there any processes that may have backdoors? And then they'll kill those connections. If the process is already on disk, you know, let's get rid of the process while it's running, so it's not like it's there all the time on disk. And the cool thing about this is if you start doing some more research around this area, if you actually Google pkill and the name of a miner, such as like minerd, you'll find tons and tons of these scripts on Pastebin or on, you know, GitHub gists where attackers have stashed these, or people have found them on their servers and posted them on Pastebin saying, hey guys, what do you think of this? So it's a pretty solid walkthrough of it. What we have found effective to kind of key off of detection with these is actually, believe it or not, keying off of the pkills, because it turns out that admins in their environment don't say pkill minerd a lot.
Right. We hope they don't, right? Yeah.
Well, and the thing is, if you do have an admin that has that, chances are you're going to want that anyways.
Yep.
Want that alert anyways.
Yeah, that actually brings up a good point, Tony. I was going to ask, like, so obviously monitoring endpoint or server command lines, process monitoring. Are there any other data sources that a defender could use to observe this? So proxy, network, what would be other, like, where would I see this activity outside of, say, process monitoring?
No, definitely. So starting off EDR process monitoring stuff, depending on your technology, you may or may not have a high level of fidelity. Not all EDR products are equal across all platforms. So that's something you definitely need to test. On most, if not all Linux systems, you'll have audit D. So you can show audit rules for when certain files are modified. You can show when certain files have been executed, network connections have been executed in specific ways, certain system calls have been performed. Audit D can be a little bit of wizardry, and if you really know how to tune it and get the right rules down, and then figure out a way to get the rules off the box and into a platform of some kind to really show it at scale, it's really awesome. A lot of people have struggled with audit D rules, though. It really depends on your particular environment and how you're set up for it. On the network telemetry side, the parts that will be keyed for network telemetry will definitely be the curl downloads and the CookieMiner connections. So let me see. Yeah, like the curl downloads.
I was thinking of, yeah, like if you like maybe monitoring outbound connections from your Linux systems, depending on what services they're running. Typically, they would be receiving requests, but in this situation, you have an outbound request from your Linux server to paste bin or get. That may be an indicator as well, either via DNS or the network calls. Yep. Okay.
Absolutely. And your proxies are probably going to have URLs that you can look through on the logs. Compare that against your established baselines if you have any for the Linux servers. The Linux boxes, when tuned properly, and they're not going to have a lot of stuff that's going out to the internet for things that are different from your baseline. Linux stuff is fairly good about, you can kind of set them in a spot and they'll stay there for a few years doing what they know until something comes along and changes that inertia.
Yep.
And if you do have a proxy, you'll end up being able to hopefully pull down these payloads out of a proxy cache if you, if they get cache in that fashion. There was something else on the network side, proxies.
Are there any particular host headers that would be present if you're inspecting HTTP or HTTPS, or
it would just be the standard stuff like host headers, the standard HTTP stuff. Oh, the one I was thinking of was the CookieMiner traffic. This isn't necessarily something that you would catch with a proxy, but it would be good with network analytics. What I've always been told is to look for something that resembles a poker hand. So if you have 4 7s, 4 3s, 1 2 3 4, something that's kind of an odd, what you would term like a poker hand port coming off of one of these servers, it might be something good to investigate. I'd have to go back and look specifically what ports that they would use for the ROC actor, but looking through, again, these are chunks of code that I took directly from their payload. So like, in fact, one of the things that ROC would look for is, again, like poker hand type ports.
I'll never be able to look at port numbers again. Totally.
Yeah, poker hand ports.
Solves everything.
That was a straight flush attack to a three of a kind.
Oh yeah. So I believe that should be it for the rock and roll one. Do you guys have any questions, anything before I dive into the last one, the Mirai one?
Let's pause for just a second and see if anyone has a question. This is great stuff. I want to make sure if anyone has questions about the activity that Tony's presented in the test or detection. So let's just pause for a couple seconds. If you do have a question, there's a Q&A spot. You can type that in, or you could type it into the chat. Either way, I don't see any coming in. So, but let's give people a second to maybe form the questions. So that's good stuff, Tony. Thanks for writing those up.
Oh, no
yeah,
problem.
it's amazing. Excellent work.
And I realized in this that I may have left out the good part, because if you want your test to have a little bit more teeth, there was a line that Rock used in one of their payloads that was called the preload trick, where they would download an additional, like the Linux equivalent of a DLL, a shared object library, and they configured a file to make it preload that every time PS was executed, and it would actually hide their mining process behind the scenes.
That's cool.
That's like the LD it's kind of like DLL injection, LD preload attack on Linux, right?
It was exactly that, except it wasn't the LD preload variable. It was actually a file that you can modify on the file system.
Fascinating. Okay.
That the lib process hider piece?
Yes, that's exactly it. That's exactly what they used. They added their own misspellings to the project and hid the KWorker DS process.
Gotcha. So yeah, someone just made a comment in the chat, Tony, just about PCAPs potentially being a way to grab the data. Are you seeing these go pastebin over encrypted HTTPS or clear text, or is it a mix, do you think?
You know, that's actually something I'd have to go back and look at the payloads about, because I know pastebin is capable of HTTPS, so that would be hard to pull out of a PCAP unless you have some sort of SSL termination or stripping going on at the edge of your environment. And SSL stripping and termination stuff, that's an odd game to get into anyways with privacy.
Yep. Okay, that's cool. Yeah, I was just curious. That question came in the chat. So I think we're good. I didn't have any other questions come in. So Tony, if you want to take us through Mirai.
Oh, sure.
We're great on time. So thanks again for taking us through this.
Oh, no problem at all. And the last one wanted to talk about was Mirai. It's fairly simple, fairly straightforward. And you may be thinking, wait a minute, this is Atomic Red Team. We do this on data center systems. We do this on servers, on clients, everything like that. This to me is it's kind of a quiet sort of chain reaction to add in, but to me, it's a big milestone, because this is kind of the moment where you can take Atomic Red Team and you can extend it to your Internet of Things devices. If you really want to test the Raspberry Pis out in your enterprise that are powering the digital signs on the walls, this is a test that you could easily adapt to, running on a Raspberry Pi. If you have any, Internet of Things devices that are exposed to the network with vulnerable web apps, and you wanted to test what a Mirai infection would look like, this would be a good way to do it. Anybody that's not familiar with Mirai, several years back, there was a big distributed denial of service botnet named Mirai that would compromise Internet of Things devices that were available publicly on the internet. So we're talking DVRs, routers, Raspberry Pis, all this different crud. And after Mirai's big heyday, the author of the botnet published the source code for Mirai. And since then, there have been a bunch of derivatives come out, like the Ghost botnet or not Cestus, but just a bunch of different ones. And they all follow the same sort of pattern, because it's just people who are repackaging the source and giving it a different name. The cool thing with this, just like with Rock, you can Google search, and knowing the right combination of Google searches, you can actually find open directories of Mirai derivative malware across the internet. And sometimes you'll even find the shell script payloads that the adversaries, the attackers, will download. And they all seem to follow relatively similar pattern to this. So the first step, we're going to be changing directories until we find one that's writable, figure out what architecture we're running, download our test payload and name it after, Mirai or GhostNet or something that's going to be similar to what we see out in the real world. Add an execution permission to it, execute it, and then remove it. Gotcha. And this is the quick sort of exploit, execute, removal chain, and that binary will keep running in memory. Well, this one should exit rather fast because it's a test one. But if you wanted to replace this with something that's a little bit longer running, if you wanted to to modify the C code in it and add like a weight or something like that until there's input. You could have that be a very long running process and then test out what it would look like in your telemetry. If you're going to be testing this on IoT devices, you may find that the payload we have included in the repo might not run on your IoT devices. This is because it's compiled for x86. Okay. Yeah, that's, what was that?
No, that's good. Yeah, that's good to point out for sure. Yep.
Yeah, they, we can't really, or I would say that we probably could, but it wouldn't be really time effective to get a payload for every single architecture that's out there like Mirai does, because they have one for MIPS, they have one for ARM5, ARM7, all the different IoT architectures or mobile architectures, things like those. So what I would advise is taking the atomic hello.c code, which is in the chain reactions folder again. Just a simple little hello world in C, compile this for ARM5, ARM7, and then host it on your internal network. And that would be something that you could definitely launch on your, digital signs, on, whatever infrastructure you have that's IoT that is ready to exploit.
Tony, what was the, and just because I'm not super familiar with Mirai, what was the initial access? Like, was it an exploit or was it like a web server injection? Like, what was that harness to get to trigger that payload? Does that make sense?
Yeah, so I'm trying to remember for the initial one with Mirai, but the derivatives now that are going around, pretty much all of the derivatives will target home routers, IoT devices that are publicly accessible to the internet that have a remote code execution vulnerability in the web app.
Okay, that's what. Yeah, that makes sense. Okay.
And then what they'll do is they'll have again a bash-c, which does a curl or wget to bash, which I should have put that as like stage 1 in the Mirai part here. I just skipped directly to the chase. But that's pretty much how it goes with the Mirai derivatives. Is there's a RCE that's been found in a D-Link router web interface, or in now I'm trying to think of some of the other ones.
Or something. Yeah, some service they've exposed.
Precisely.
That would be actually an interesting dialogue, or maybe follow-up would be like, what are these appliances or devices that are at your edge? Because it would certainly be interesting probably to attackers to route through those to get out, because there's no telemetry instrumentation on the company doorbell that is connected to the internet, right?
Precisely. And we're living in an age where it's getting easier every day to buy a vendor supplied appliance. Like if you go buy like a MCS or a Prime appliance from Cisco, that may be running CentOS, or it may be running something under the hood that you don't necessarily have telemetry on. It's something that can still be executed. You can still have code execution on it. It can still be vulnerable. It still has to be patched. But how many times do you buy something that's an appliance from a vendor and say, all right, let's throw a sensor on it?
Right. That's a good point. Yeah, a lot of times they don't allow you to extend the OS or put code on there because it's a closed system. So
exactly.
Okay, yeah, that's really good. That's thanks for answering that. I was curious about.
Oh, no problem at all.
What the state of the art is for this one. So okay. Awesome. Any questions from folks that are attending on Mirai, or Tony? Anything else to add? It looks like there's somebody just posted. Someone also mentioned default creds.
Default creds.
By Mirai.
Yeah, because nobody changes the creds on their webcams and routers.
Yep.
Another one that I've also seen kind of mentioned in some articles was SSH brute forcing with default creds and kind of simple word list brute forcing. It's just a bad idea to have publicly available IoT things. Sometimes you can't avoid it, like with routers. That's part of the nature of the beast. But anytime that something's publicly available, this sort of thing rears its head.
Yeah, I thought I read, I'll have to look up the resource, but it was something within the neighborhood of like when you attach a device, it's like within 30 minutes to an hour, it'll be scanned or with just sort of constant background hum. So yeah, that's really good, Tony. Cool.
UPnP. Well, I like that.
Awesome. Yeah, go ahead, Tony.
And we're also living in the age of Shodan as well, where if you're not aware of the stuff that's running on your home network that's publicly accessible, it might be something to go towards Shodan and see if you can scan the IP address, scan the materials that represents your network, represents your enterprise, and see what's publicly accessible. That's something I ended up doing at my last job before coming to Red Canary, was trying to figure out, okay, exactly what in this IP space is accessible, and let's see if there's a webcam or something that we just don't know about.
Yep, that's good. I like it. Awesome. Well, any other questions, Tony? Is that anything else to take us through? So we went through really kind of those three scenarios. Hopefully those are helpful. People, we're definitely seeing those out there. So those are good tests or chain reactions to run to make sure you've got the ability to observe that behavior, whether it's network or endpoint. So awesome work, Tony.
That works. All right, so I'll go ahead and stop my share here.
Yeah, that's super cool. I'm excited about those.
Yep.
If you guys have any questions, feel free to ask. I'll be here to the end of Atomic Friday. If you guys have any questions and don't think of them now, or coworkers have questions, I'm Forensic IT Guy on Twitter. Feel free to ask. Feel free to post in issues in GitHub, in the Atomic Red Team Slack. I'm here by name. Come find me, ask questions. I'm more than happy to help out.
Awesome. Thanks again, Tony. Really appreciate you taking us through that. That's really good work.
No problem.
All right, Haig, you're up, man.
All right.
Switching gears. Windows.
Yep. Back to Windows. Yes. All right. Internet seems stable. We're good. We're making it.
Yeah, it looks great.
All right. Let's bring this over here so I'm looking at the camera. So we got some feedback internally from part of our team asking about the ability to install Atomic Red Team. And you still see my screen, Casey?
I'm looking at the Atomic Red Team IO is what I see there right now.
All right, let me just make sure it's shared safely. But so the feedback was, hey, we want to be able to get going with Atomic Red Team real quick, get spun up, and just be able to start executing tasks. It's okay.
That looks good.
And we started. Okay, cool. Thanks. We saw that our setup guide was a little tricky, required the dependency of PowerShell YAML. You had to run through things, and then to actually execute the test, it took a little bit of work. There's like 6, 7, 8 lines of code to execute all the tests or generate all the tests. And so we kicked off a project to go and build a quick installation script. And so if you haven't been to our Atomic Red Team IO page, this is the standard page that is available to everybody. It's on our, it's all marked down and whatnot. Has our use cases, philosophy, all that getting started. Click the view on GitHub, and if you're not on our Slack group, you have a quick link to our Slack group there to sign up. So I'm going to shift right over to our Atomic Red Team repo here, and this is where we have our. Make sure we got no post. Okay, cool. This is where we have our new link or our new installation script. It's going to be under Atomic Red Team Execution Frameworks, Invoke Atomic Red Team. And within here, a while back, it was committed, Invoke Atomic Red Team was committed, and this allowed for us to query all the YAML files, generate the test, execute the test. And so now we created a actual installation script that allows for you to just run the script. It will download Atomic Red Team, the full repo. It'll install the dependencies. It'll set you up 100%. And then you're just in the path of Atomic Red Team to literally just start executing tests right away. And so, yeah, it imports the module. It does everything for you. So there's no more having to figure things out, generate things, and go from there. Were you gonna say something, Casey? You good? Awesome. So This is all updated. I'll drop the link right now in case anybody wants to follow along. I'll put this into the Slack on Zoom so everybody has it. Here we go. And that's got to open, of course. So I'm just going to open up the script real quick. So this is our install Atomic Red Team script. It does require to be ran as administrator. We have 2 parameters built into it, so you can actually specify during install if you want it to install to a particular directory. So like C Atomic Red Team's default, you can tell it C temp, C tools, wherever you want to put it. We also put download path. So if you want it to be downloaded to your downloads directory and then have it installed into a different directory, you're able to specify those 2 things. So whatever you want to do with it, it makes it pretty easy and fluid. Everything in here, it's all pretty much set up. We have all of the examples in here as well. To literally just kick this thing off, if you just download the repo and just run install Atomic Red Team, it'll just dump it all in there for you, ready to go, and you're able to get started.
Yeah, it downloads the zip and decompresses it to that download path as well. Yep.
Yeah, yep, exactly. So yeah, this down here is just literally what it's going to do. So you tell it the path you want to ship it to, install it to. It goes out to the repo, downloads the zip file, it unzips the file, and just sets you up, installs everything else, and you're good.
Quick question, if I may.
Yeah, go for it.
Whenever I tested this on the VM, I forgot to test this part. But if I remember, there's supposed to be some stuff that you have to do with unblocking certain PowerShell scripts or binaries whenever you need to execute them.
Yeah.
Is that included in here?
Yep, it sure is. We have the set execution policy set to unrestricted right at the beginning. Yep.
Okay.
So run it as administrator. It already puts it to unrestricted, and then it finishes the rest for you. Yep, great question. So I have my environment ready. I figure I'll go ahead and demo it. I don't have Atomic Red Team installed right now. So what I did right here is I just downloaded the script from the repo. I'm just going to execute it locally from my C drive tools directory, and it's just going to go. Again, it's fairly easy once you click the enter button in the proper window. Maybe it goes, maybe it doesn't. There we go. So now that it's running, it literally just creates that C Atomic Red Team directory. You'll see it in my background there. Here it is downloading. It already downloaded the master zip file. This is it expanding that zip file into Atomic Red Team, and it just completes the rest from there. It's kind of like watching paint dry at this point.
Yeah, I think this is helpful not only for teams that want to do automation with Atomic Red Team, but also for folks that a lot of people use Atomic Red Team during POCs, either of Red Canary or other EDR vendors. So this, like what Mike's creating here, just really abstracts some of the complexity away for you to stand up a test VM and get off the ground for your test coverage if you wanted to. So.
Yep. Yeah, I've kind of envisioned it. I think you've probably seen this too, Casey, where like you have like 4 or 5 VMs and you don't want to go through all 5 of them installing Atomic or putting things on them. You could just kick off that remote PowerShell, download Atomic Red Team, and it just sets them all up, puts it in the directory you need it, and then you're able to start executing things from there.
Yep, I think the one caveat is we do have a safety handler there to make sure you're admin. You do need to be admin to require that YAML module to install that. So
yeah,
something to think.
Yep, exactly. Yeah, and so that was it. It's installed. You're now ready to invoke Atomic Red Team. So the next piece I'll show here real quick, and then we can hop into any kind of questions. And this is all documented here on the repo on that README file. And then the getting started piece right here. So we give you the two functions of generate all the tests, or you can actually execute all the tests. So this is a new script, a new module that we just added, which is invoke all atomic tests. And this will, again, generate or execute. And so, I don't know, Casey, 50-50, what do you pick?
Just do generate for now, because that'll just dump the each test to the screen, which is sufficient for now. Yeah.
Cool. So yep. my font size and that long path skewed this. So invoke all tests. I'm going to do generate. I can type in the correct windows. Generate only. That was tab autocomplete because again, it's all built in there. So now you just tell it your path. So my path for Atomic Red Team is right where we put it. So Atomic Red Team, and then Atomic Red Team master / atomic. So I'm telling it where all my test files are located. And then, and I think, Casey, this is actually built into it as well. You can tell it your path as you execute, right?
Right.
That
one of the arguments is tac path. Yep. Yep.
And then default is Y.
Good point.
Just hit enter. It doesn't matter.
I think it can be helpful because sometimes people want to use Atomic. Some of the feedback we got was they may not want to execute right away. They may want to stage or generate the test script on a system and then move it into a production environment or test system. So what essentially is happening here is just going through and carving out all the YAML and then dumping the actual test command lines, which is going to be bookended with a begin and an end test block. And then you would literally just move that into whatever system you wanted to execute. So, yep. Cool. We did have a question, Mike. While that's running, you could probably just kill it at this point. I mean, Control-C or whatever. But
yeah.
Someone had a question about constrained language mode. And so just to make sure everyone is at least familiar with that, and then how we address it in Atomic, I'll go ahead and take that one real quick. So constrained language mode in PowerShell is a way to restrict methods, property setters, and some of the other function calls and objects you can create in PowerShell. So it really locks that down. Today, we don't have any tests that would operate within constrained language mode. It's probably something that we could have a discussion in the Atomic Slack channel, or maybe put an issue on GitHub and see how we would work around that. So, sort of by the nature of the way constrained language mode, we are dependent on PowerShell being unrestricted to execute. So hopefully that answers your question. Does that make sense? Okay. Okay, another question came in is how do we clean up, automatically clean up the post test cases that are executed? That's coming right now. We don't have a cleanup routine. Some of the scripts do, but it's definitely, this is something that would be run on, the idea is a test system, because we modify registry keys for like COM hijacking, we change account credentials.
A lot of files.
Yeah, there's dropping a lot of data. So it's a good point. The two things that we're coming will be like things like additional reporting and some cleanup. So you could say like run Atomic and then roll back Atomic. So yep, it's a good point. We just need to add that. Good stuff. Okay, sweet. Carry on, Mike.
Man, that's actually it. I mean, we got our install script, we got our new generate invoke all Atomic tests. I mean, that's easy enough,
Yeah, so I guess the thing now, we've got it in the main branch, so please test it, give us feedback. We've got a couple people field testing it here internally as they see customers using it, so hopefully we can iron out any bugs and improve it. So yep, give us feedback. So awesome work, Mike. Good stuff.
Yeah, man. Thank you so much. Thanks for your help on it.
So so we're kind of closing in on time. I think the one last thing I just wanted to show real quick, there looks like a question just came in. 1 second. I have to read the questions before I just start reading them online. You troll me with questions. So Mike and Tony, talk amongst yourselves while I read the question.
Pause. Dramatic effect.
So, well, yeah, while Casey is reading the question, the reason he has to read the questions is because we did have a webinar one time where somebody was asking about how facial hair was styled.
Yes.
And I was just like naive webinar host, and I was just reading. I was like, so what do you think about? No, okay. So these are actually really good. So one person asked a question about like when they're running the test, AV is killing the test. That's certainly a positive outcome because it tells you a preventative control is working. A lot of the philosophy around Atomic would be after a preventative control may have failed or execution occurs. So we downgrade most of our systems intentionally to then exercise telemetry generation. So we sort of expect that a lot of our tests will get caught by AV, and so we operate that would be turned off on a test system. Again, it depends on what you're testing. If you want to test to make sure AV catches like invoke Mimikatz, then leave that on. That's great. That's good. That's good. A good data point. If you wanted to test if something would be able to execute after the fact, then you would definitely want to go ahead and disable AV and then execute it. So, so that hopefully that answers the question specifically around techniques. We don't include specific evasion tactics for AV. We don't really want to get into that game as far as like providing specific binaries that may circumvent defensive controls in that regard. So
yeah, I think from like that perspective, we've always seen it as like, if it's something you need, like build it and add it to Atomic, you know, pull that fork, build like the exact thing you want to make. Maybe it's custom payloads with Veil or whatever it might be.
Yep.
Like kind of like take what we've like foundationally built and then like make your own thing. And then maybe it turns into something where you actually push it in and you know, we begin to ingest it into the project itself. Like I was just thinking in my head, like
exactly, great point. Yeah, extend
right?
Atomic as you need to. So like if you want to take one of our DLLs or C# scripts, run it through Veil evasion, for example, or something like that. That would be something we would expect a defender to do to test, but we don't really provide those payloads. So hopefully that answers that question specifically. The second question that came in was around report generation after execution. And this is probably the next big thing on our wish list, because we would like to be able to correlate a test to telemetry downstream in your whatever your system is, Splunk, or whatever you're searching in, your EDR tool, or whatever you're collecting in. So that is hopefully coming. We are open to ideas on that. Mike and I were looking at Pester as a potential way to track and log like start and end times and put assertions into the test, but that's probably a good conversation for Atomic Slack to go through those. What's the best way to do reporting, and what's the best way that makes sense for people to then consume the outputs? A lot of people have a lot of different expectations on that, so we would probably go with the most basic CSV XML thing, JSON, and then you would be able to parse and consume it somewhere else. So hopefully I answered those two questions that came in. So
may I add something there?
Yeah, go ahead, Tony. Of course.
So right now, talking about the report generating after execution, to me, one of the big things in my mind that is separating the free products in this space, the free projects like Atomic Red Team Automation from Endgame, Caldera, the other sort of things. The big thing that separates the free projects from the paid products are the time and automation behind doing the measurement after the fact.
That's a really good point, Tony. Yeah, that's actually really good to bring up. Like I think the Atomic is a gateway framework to maybe a more advanced or more, as you start testing, you may find you want to deliver it to different systems and different things that you find you may graduate from Atomic, and that's fine too, certainly. Yeah, good point, Tony.
Okay. El Camino, remember?
What's that?
The El Camino.
Oh yeah, the notepad of the EDR testing world. El Camino. We get the job done. May not look great, but it works. So.
It's a car. It's a truck. It just does it, right? I mean.
I think thanks to everyone in the community, a lot of people have contributed it, and it's really gone a lot farther than I think we thought it might go initially. So it's fun to see, but awesome. Well, I think we're closing in on time. I don't know if Mike or Tony, if you guys have anything else. I have one last thing to show, and then we'll kind of close this session out. So you guys good? Good? Okay.
Good.
Let me just share my screen. This is the one thing. This came up in an event that we had yesterday or whatever, I forget. Yeah, maybe Wednesday. The idea was how can you do some analysis on MITRE ATT&CK? And so I wanted to give a shout out to ER&W. They put together a really good, and let me just paste this link into the chat so you guys have it. If I can do this, hold on. There it is. Okay, so that's what I'm showing on the screen now. So Miner updated their API, and so this is a really good PowerShell script that lets you basically get the attack techniques and look at metadata. And so what I wanted to show here was just really quick. A lot of teams are struggling with like, what kind of analysis or where do I start? And so I'll post this just in our Slack, but I basically took that PowerShell script and flattened all the data sources that are in each technique. So what you can do is create like a pivot table, and you end up with an analysis where you say, like, if I had to go for one thing in visibility or one area to go after, what would it be? And you'll find, if you look at the data, process monitoring, sort of the tall pole, it stands out with, like, of the 223 techniques, 157 of them would be observable in the data source process monitoring. Whatever that is, could be Sysmon, could be something else, but that's just an idea, like, where do I start getting visibility, or do I even have the ability to observe this technique? Maybe consider some of this analysis in that ERNW script to just pull it down and start pivoting and thinking about, coverage and some of those things. So just wanted to give them a shout out. It's a cool script, easy to use. So I'll pause there. Any questions on that or things we've covered today? Thanks again for joining. Looks we had a pretty good turnout. So a couple of other question there. Cool. Okay. Well, so I'm going to close it out. Yeah, go ahead, Mike.
We have one more question, or I guess it wasn't a question. I think it was feedback there. The one right above the link, right above your simulator.
Yeah, gotcha. Okay. Sweet. Yeah. So yeah, really good stuff. Keep contributing. For those of you who are new to security, this is a really good way to learn a technique or dive in, start writing some code, understand a payload. We'll help you through the process of learning Git. I'm terrible at Git, so we'll have someone else make sure we get you up to speed. But it's a fun way to learn, contribute to the project. So we really do appreciate it. Wanted to say thanks for everybody that's done that. So unless there's anything else, I think we'll close this out and watch Twitter for the YouTube link and reference if you want to come back. It'll probably be on our YouTube channel as well. So thanks again for attending.
Awesome. Thank you, everybody. Have a good day. Thank you, Tony.
Thanks, guys.
Thanks again, Tony. Great stuff.
No problem. Thank you.
Thanks, man.
Bye. Yep.
See you guys.